Hello friends, welcome to our channel. In today's session, we will see the examples for basic transformation functions. And in the previous class, we have already seen the different basic transformation functions, translation, rotation, and scaling. So basically, these transformation functions are used to manipulate the object. So that means changing the position of an object, rotating an object, or resizing an object, changing the size of an object. So those manipulations we call it as transformations. So three transformations we have seen, that is translation, which changes the position of one object from one place to another place. So here in this translation we require two translation parameters, that is tx and ty. So these tx and ty are the distances with respect to x-axis and with respect to y-axis. Tx is the distance parameter to translate the object from one position to another position. And next, rotation, and this rotation is rotating the object with a certain angle theta. So we require a theta in order to rotate the object. And this rotation can be clockwise rotation or anti-clockwise rotation. So that rotation may be any one among these two. And coming to this third one, the scaling, it changes the shape and size of an object. So the change of size and shape of an object depends on two parameters, that is scaling parameters sx comma sy. So if both sx and sy are not equal, it indicates change in shape. Change in shape. If sx is equal to sy, then no change in shape of an object. And if sx and sy are less than 1, size of an object decreases. If sx and sy are greater than 1, the size of an object increases. So scaling means changing in shape or size of an object. So if both the scaling parameters are not equal, it implies there will be change in shape. If both the scaling parameters are equal, it indicates there is no change in shape. If both the scaling parameters are less than 1, the size of an object will decrease. If both the scaling parameters are greater than 1, the size of an object increases. Now let us take a different examples for for all these three transformation techniques: the translation, rotation, and scaling. So as we have discussed in the previous session, we have derived a formulas for translation, rotation, and scaling. Now let us take an example and we can solve that. So first one is translation. For this translation, we require translation tx and ty. So tx is a translation parameter with respect to x-axis, ty is a translation parameter with respect to y-axis. So we have derived x dash, and xy are the old coordinates and x dash y dash are the new coordinates. So x dash is equal to x plus tx, y dash is equal to y plus ty. So this we have written in matrix representation: x dash y dash is equal to tx ty plus x This we have done. Now let us take an example. Let us take an example. Consider a square with coordinates 0, 0, 2, 0, 0, 2, 2, 2. And we have to translate this square with translation parameters, 2 units with respect to x-axis and 3 units with respect to y-axis. Let us draw the square before performing the translation. So 1, 2, 3, 1, 2, 3. See, first 0, 0, 2, 0, 0, 2, and this is 2, 2. So this forms a square translation. Now let us consider and let us solve the following example. First, consider 0, 0. Apply the formula x dash is equal to x plus tx. Here it is x and it is y. So 0 plus tx2, that is so the point 0, 0 after translation becomes 2, 3. This is one point. Consider the second point 2, 0, 2, 0. And here this is x and this is y. So x dash is equal to 2 plus 2 is equal to 4. Y dash is equal to 0 plus 3 is equal to 3. So 2, 0 becomes 4, 3. This is the second point. And coming to the third, 0, 2. So this is x equal to 5. So 0, 2 becomes 2, 5. Similarly, the last point 2, 2. So this is x and this is y. So x dash is equal to 2 plus 2. So x plus tx is equal to 4. Y dash is equal to y plus ty. So 2 plus 3, that is 5. So 2, 2, it becomes 4, So after translating the given square with the 2 units towards x-axis and 3 units towards y-axis, we get the new points 2, 3, 5, 4, 5. Let us draw the graph here. Two, 3. Four, 5. So this is a square after translating tx is equal to 2, dy is equal to 3. See here the graph changed here. So that means the position of a square is modified. So this is before translation and this is after performing the translation. So we are changing the position of an object. So simple. We have already derived the formula. So we have to consider each point and we have to apply the formula and we have to find the new coordinates. So x plus tx, here x is 0, tx is 2, ty is 3. So 0 plus 2 is equal to 2, y dash is equal to y plus ty. So y is 0, ty is 3. So 0 plus 3. So after calculating, again we have to draw the graph so that we can show the change of the position. Next, hope you understood this translation. Let us move on to the rotation. Right. So in this rotation, there are two cases. One is in a clockwise direction and another one is in anti-clockwise direction. First, let us see the anti-clockwise direction. So for both the cases, we have already derived the formulas and just we have to apply in example. Right. Let us consider a triangle here with the vertices 0, 0, 0, 1, 1, 1. So why I have taken this triangle? Because if you rotate the square, we need not. That means we can't see the change. So if you take the triangle, we can easily observe the change if we rotate the triangle. So first, let us draw the graph before rotation. 1, 2, 3. 1, 2, 3. So 0, 0. So this one. 0, 1. This one. 1, 1. Sorry. Let us take a 1, 0. So that let us consider this triangle. So we are rotating this triangle with an angle 90 degrees in anti-clockwise direction. Anti-clockwise direction. That means we are rotating this triangle in this manner, in a 90 degrees. Right? Now let us write the formula. X dash y dash is equal to, so this is anti-clockwise. So the formula is cos theta minus sin theta cos theta into x y. So this is the formula which we have derived for anti-clockwise direction, rotation towards anti-clockwise. Now, as we know that sin 90 is 1, cos 90 is 0. Now consider the first coordinate 0, 0. So x dash y dash is equal to cos 90 0, sin 90 minus 1, sin 91 0 into 0, 0. So if you multiply this 0 into 0 minus 0, 1 into 0. So automatically here x dash y dash is equal to 0, 0. So 0, 0 doesn't change its coordinates after rotating in 90 degrees. Now let us consider the second point, 1 comma 0. 1 comma 0. Again x dash y dash 0 minus 1 1 0 1 0. So we will get 0 into 0 0, sorry, 0 into 1 0 minus 1 into 0 0, 1 into 1 1 plus 0 into 0 0, so 1. So our coordinate 1 comma 0 becomes 0 comma 1. Now let us consider the third point, 1 comma 1, and apply here x dash y dash is equal to 0 minus 1 1 0 into 1 1. It becomes 0 into 1 minus 1, 1 into 1 plus 0, so 1. So here 1 comma 1 becomes minus 1 comma 1. So after rotating the given triangle in 90 degrees towards an anti-clockwise direction, 0 0 becomes a 0 0, and 1 0 becomes 0 1, and 1 1 becomes minus 1 comma 1. Now let us draw the graph so that we can observe the change. So this is the first point, 0 comma 0. Next 0 comma 1. So this is the 0 comma 1 and minus 1 comma 1. So this is minus 1 comma 1. So this is the triangle rotated. After rotate, sorry, just so this is the 1 comma minus 1 comma 1. See, this is the first point, this is the second point, this is the third point. So after rotating the triangle in anti-clockwise direction at an angle 90 degrees, our diagram looks like this. So based upon the direction of rotation, we need to change the formulas. So this is the formula derived for anti-clockwise direction. So if the direction of this rotation is not mentioned in the problem, by default we can consider that rotation as an anti-clockwise direction. So if it is a clockwise, automatically it will be mentioned in the problem. Now this is an example for anti-clockwise direction. So we have to consider each point and we have to calculate the new coordinate based upon this formula, and we have to plot the graph. Now let us change this one, second case. Now we are rotating clockwise direction in 90 degrees. The same problem, the same formula, the same coordinates, but we are now rotating in clockwise direction. Consider the formula. Once again we have to write the formula. Now this formula will be changed. So x dash y dash is equal to cos theta sin theta minus sin theta cos theta into x y. Now again here we have to consider the each point and then we have to find the new coordinates. Consider the first coordinate 0 comma 0. So x dash y dash is equal to 0 1 minus 1 0 into 0 0. So obviously x dash y dash will be 0, 0. So 0 comma 0 remains the same even after rotating with an angle 90 degrees towards the clockwise direction. Now let us consider the second point, 1 comma 0. So x dash y dash is equal to 0 1 minus 1 0 into 1 0. So it becomes x dash y dash is equal to 0 into 1 0 0. So 0 minus 1 0. So minus 1. So 1 comma 0 becomes minus 1 comma 0. Coming to the third point, 1 comma 1. So x dash y dash is equal to same 0 1 minus 1 0 into 1 1. So that 0 into 1 1 0 into 1 0 plus 1 into 1 1 minus 1 into 1 minus 1 plus 0 into 1 0. So x dash y dash will be minus 1 1 minus 1. So 1 comma 1 changes to 1 comma minus 1. So after rotating the same triangle through an angle 90 degrees in a clockwise direction, so the coordinate 0 comma 0 remains same, 1 comma 0 becomes a minus 1 comma 0 and 1 comma 1 becomes 1 comma minus 1. Now let us draw a graph for these new coordinates. The first point is 0 0, this one. Second point is minus 1 0. So minus 1 0 means this one. Next point is 1 minus 1. Sorry, once let us check here. 0 into 1, 1 into 0. So 0 comma minus 1. Yes. Here we have written wrong 0 comma minus 1. So 0 comma minus 1. So 0 comma minus 1 means this one. 1 comma minus 1 means this one. So the triangle becomes, so this is 1 comma minus 1. So after rotating this triangle with an angle 90 degrees in a clockwise direction, so 0 comma 0 first coordinate, and then 0 comma minus 1 0 0 minus 1 0. So 0 comma minus 1. So 0 comma minus 1 means this one, x0 y minus 1, yes, this one, and 1 comma minus 1, so xy minus 1, so this one. So this is the process to calculate the new coordinates if we rotate and triangle in 90 degrees in a clockwise direction. Hope you understood this rotation, and now let us move on to the scaling function. So here we require two parameters with respect to x-axis, with respect to y-axis, and similarly xy are the old coordinates, and we need to find x dash and y dash. For that we have calculated x dash is equal to x into Sx, y dash is equal to y into Sy. So for this scaling, we have derived a formula. So x dash y dash is equal to g Sx 0 0 Sy into x y. Now let us consider the same example which we have considered for the translation. Consider a square with the coordinates 0 comma 0 2 comma 0 0 comma 2 2 comma 2. Now first case, scale this square with Sx is equal to 2 and Sy is equal to 3. So in this case, these both the scaling parameters are greater than 1, so automatically the size of an object will increase. So the size of a square will increase. And one more thing, here Sx and Sy both the parameters are not equal. That means the shape of a square also changes. Let us draw the triangle square initially. So first 0 0 2 0 0 2 2 2. So this is the square, initial square. This is 2 comma 2. Now here we have given that Sx is equal to 2 and Sy is equal to 3. That means we have to perform the scaling of 2 units with respect to x-axis and 3 units with respect to y-axis. Now let us consider the first point 0 comma 0. So x dash is equal to x into Sx. So 0 into Sx means 2, that is 0. Y dash is equal to y into Sy, that is equal to 0. So 0 comma 0 remains the same even after scaling with 2 and 3 units with respect to x-axis and y-axis. Coming to the second point 2 comma 0. So x dash is equal to x into Sx. So 2 into Sx is 2, that is equal to 4. Y dash is equal to y 0 into Sy, that is 3, is equal to 0. So after scaling the second point 2 comma 0 becomes 4 comma 0. Coming to the third point 0 comma 2. X dash is equal to x into Sx, 2 is equal to 0. Y dash is equal to 2 into Sy, 3 is equal to 6. So 0 comma 2 becomes 0 comma 6. Next, fourth point 2 comma 2. Let us consider x dash is equal to 2 into Sx, 2 is equal to 4. Y dash is equal to y 2 into Sy is equal to 3, that is equal to 6. So 2 comma 2 becomes 4 comma 6. So after scaling the given square with the 2 and 3 units towards x-axis and y-axis, we get the points 0 comma 0, 4 comma 0, 0 comma 6, 4 comma 6. Now again draw the graph. Let us draw the graph. Zero zero, so that is this point 4 0, so this point 0 6 0 6, this point 4 6 means this point. So here we can observe that the square becomes rectangle. when Sx is equal to 2, Sy is equal to 3. So the size increases so that the shape also changes, because here we have taken the scaling parameters, both are not equal and both are greater than 1. So let us try the second example with considering both the S and Sy and Sx as less than 1.5 and Sy is equal to 0.5. Here in this example, we are taking both the scaling parameters as 0.5. So first thing, both are equal. So if both are equal, the scaling will be done uniformly towards x-axis and y-axis. So the shape of an object will not change. And these two scaling parameters are less than 1. So automatically the size of an object will decrease. So let us see whether it is right or wrong. X dash is equal to x into sx, y dash is equal to y into sy. Let us consider the first one, 0 comma 0. So x dash is equal to 0 into 0.5 is equal to 0, y dash is equal to 0 into 0.5 is equal to 0. That means 0 comma 0 remains the same even after performing the scaling of 0.5 units in both the x direction and y direction. So here the scaling will be done uniformly. So next point, consider 2 comma 0. So for 2 comma 0, x dash is equal to x2 into 0.5, that is equal to 1. Y dash is equal to 0 into 0.5, that is equal to 0. So here the 2 comma 0 becomes 1 comma 0. So after scaling with 0.5 uniformly, 2 comma 0 becomes 1 comma 0. Consider the remaining 2 points. So 0 comma 2, x dash is equal to x0 into 0.5, that is equal to 0. Y dash is equal to 2 into 0.5, that is equal to 1. So 0 comma 2 becomes 0 comma 1 after scaling. And consider the last point, 2 comma 2. X dash is equal to 2 into 0.5, that is equal to 1. Y dash is equal to 2 into 0.5 is equal to 1. So 2 comma 2 becomes 1 comma 1. So after scaling the given square with the 0.5 units in both the x direction and y direction, the points are 0, 0, 1, 0, 0, 1 and 1, 1. So here we have to observe the 2 points. One is both scaling parameters are equal, so the scaling will be done uniformly such that the shape of an object will not change. And the second thing, these two scaling parameters are less than 1. So if those scaling parameters are less than 1, the size of an object will decrease. So let us draw the graph. So 0, 0, 0, 1, 1, 0, 1, 1. So this is also a square, but it is decreased. So this is when Sx is equal to 0.5, Sy is equal to 0.5. So this is a square. So after scaling with parameters 0.5, this square decreased. And after scaling this square with the different x and y axis, y units, the shape of the square becomes a rectangle and also the size also increased. So hope you understood these three transformation techniques. So in the previous session we have seen the derivations, and in this session we have seen some examples. Hope you understood this session. So in the next session, let us have a discussion on two more transformation techniques and the importance of homogeneous coordinates. So after that, we can see the composite transformations. Thank you.